Okay, everyone. So welcome to lecture once again. Now in this lecture, guys, I'll be talking about an important concept called as inheritance, and there are a couple of other concepts which exist around inheritance. I'll be talking about that as well. So let me share my screen and let me talk about inheritance in a very first place. So guys, inheritance is I just go after the name, so you will be able to understand that something we are trying to get, something we are trying to gain from someone else. That is something called as inheritance, right? So for example, we as a human being, so we all try to, or we all tend to, get some sort of a feature or some sort of a, special things from our ancestors, maybe from our uncle, aunt, or maybe from our parents, father, mother, or from someone. So we try to inherit some of the things, maybe the way they speak, maybe the way they laugh, maybe their hairstyle, maybe their color, and many more things, right? So we try to inherit something from our parents, from our ancestors, or from someone, right? We always do that. Now, in the similar manner, in a Python programming, you will be able to write a code, so where you will be able to inherit something from someone else. And in this way, you will be able to increase a reusability of the code even more. So how? Let's try to understand. So here, let's suppose if I'm going to create a class, right? If I'm going to create a class called as mentor class, yeah. And inside this mentor class, let's suppose I'm going to define a constructor indent underscore underscore, which is going to ask for the data at the time of object creation. So self dot name. So let's suppose this is the constructor I'm going to create, and self dot name is equals to name, yeah. So this is basically a constructor, and then I can try to say that def dot show, and here basically I can try to say that print what? So print formatted string, and print basically mentor what? So print basically self dot name, yeah. So this is a very basic mentor class I have already created, and inside that, so I have one constructor, so which will ask for me for the data at the time of creation of object, and there is a function which I have created, class function I have created. Okay, now, so once this part will be done, so once I'm able to do that, now let's suppose I don't want to use this particular class directly. So what I want is that I wanted to create a class called as Euron mentor, yeah, Euron mentor. And inside this class, I would like to call this entire feature, this entire property. How I will be able to do that? So maybe I can try to write mentor over here, mentor, and then pass, right? Pass. Now what I have done? So I have basically inherited each and everything from a mentor class to a Euron mentor. This is what I have done just by calling a mentor over here. Everything which mentor have, so everything will be available inside a Euron mentor automatically. For example, I can show you that part. So let's suppose I'm going to create an object of Euron mentor. I'm not creating an object of mentor, by the way. I'm trying to create an object of Euron mentor. Now, if I'm going to execute it, it is giving me a complaint saying that missing one required positional argument, name. See, I have created an object of what? Euron mentor, this one, right? And I have not defined any kind of a things like a name or something, yeah. But why it is still trying to complain? It is still trying to complain because it is trying to inherit, right? It is trying to inherit everything which is available inside a mentor class, inside a Euron mentor. And that's the only reason, right? That's the only reason. So that's the only reason it is trying to give me a complaint that you have to give me this value. If you're not giving me this value, I'm not going to execute it. As simple as that. So here, right? So here I have to give a name. So maybe I can try to give a name SUDH. And then if I'm going to call, right? Then if I'm going to call EU dot name, I'm able to get it. See, so without even writing any single function inside a Euron mentor, I'm able to use this constructor. I have to pass the data. Plus, I will be able to call this show with the help of this EU itself, show with the help of EU itself. So mentors danshu. So I'm able to call it. I'm able to call this function, right? And whatever is available inside this function, I'm able to print it. But via what? Via Euron mentor. I'm not using a mentor at all. So this is called as inheritance. So where I have inherited everything which was available inside a mentor, right? So I am able to inherit everything which was available inside a mentor, inside a Euron mentor, and successfully I am able to even use it. Very simple, right? Very simple. So this is the beauty, I would say, guys. This is the beauty of this inheritance. Yeah, this is the beauty of the inheritance. Now I'm going to copy the same class over here, and then I'm going to copy the same Euron mentor. So same Euron mentor I'm going to copy. Now here, so I have created the Euron mentor. So by default, when I've written this mentor over here, so by default, it is trying to inherit all these things from this mentor class to this Euron mentor class, right? By default, this init is available, this show is available to the Euron mentor class. Now in Euron mentor class, apart from this, if I would like to uh, create some of the function which is just specific to a Euron mentor class, I can do that. For example, so I'm going to create maybe a assign course kind of a function, self dot course and then a print, right? So print f of self dot name, and then self dot course. Yeah, self dot course. Now, so here, right? So here, what we are trying to do is that we are trying to create one special function inside a Euron mentor. Now, this function will belongs to a Euron mentor itself, right? This function will belongs to a Euron mentor itself. And here, so what we are trying to do, so we are remove self dot course because we are not attaching with the instances. So just keep it as a course. So here we are trying to assign one of the function which is specific to the Euron mentor. Now if I'm going to execute it and then Euron mentor, so Euron mentor, if I'm going to create an object for that Euron mentor, so obviously I have to pass a name. So let's suppose name is equal to Dhanshu. I have passed. Yeah. So EU dot. Now if I'm going to do, so it has three things. One is a assign course, one is a name, and one is a show. So name is basically a variable, assign course and show is basically a function which I have already attached, right? Function which I have already attached. Now if I'm going to call show is coming from where? Show is coming from its parent, mentor, right? So is coming from where? So is coming from the mentor. And if I'm going to write Euron dot assign courses, so assign course is coming from where? So assign course is coming from this Euron mentor itself. Now, so it is telling me that assign course takes one positional argument called as course. So, okay, try to pass that. So, one positional argument, and yeah, so whatever was there inside the assign course, I'm able to do that. I'm able to get it. So, what technically I'm trying to show you over here that you can try to inherit everything from your parent. So, this is my child class. So, I can try to write Euron mentor as a child class, and this is basically a parent class. Yeah, so it is trying to inherit everything, right? It is trying to inherit everything from the parent class to the child class, and inside my child class, so I can try to define whatever I want as per my need. That's completely fine. Yeah, that's completely fine. So now moving ahead with another example, right? So let's try to move ahead with the another example. So here what I can do is that I can try to create a small class, CLASS class called as mentor, let's suppose. And here I'm going to define one function for a mentor. So intro function, let's suppose, self. And here, so it is going to give an intro. So my name is Sudhanshu. Fine. So this is the mentor class, and this is just an intro function I have defined, which is going to print something. Okay, that's it. Now I'm going to define basically another class called as Euron mentor, let's suppose. And here inside this, I'm going to inherit mentor. Inherit mentor means This will be available inside Euron Mentor. Yeah, so this will be available inside the Euron Mentor. Now what I can do, so here, let's suppose I'm going to define intro again over here. So intro again over here, and here, so I'm going to say print, this is my new Euron Mentor. Yeah, new Euron Mentor. So see, I have done the inheritance. So obviously this function must be available here to a Euron Mentor, but same function, right? So whatever function which I had inside my parent, so exactly same function what I have done. So same function I have rewritten even inside a child class, a class where I'm trying to inherit something which is already having the exact same thing. Now, if I'm going to create an object of this Euron Mentor, right? If I'm going to create an object of this Euron Mentor, if I'm going to call eu.intro, right? Which function is it going to execute? So it is going to execute a function from a child class, or it is going to execute a function from a parent class. I'm trying to create an object of child class, by the way. Yeah, I'm not creating an object of parent class. Forget about that. So I'm creating an object of a child class. So is it going to like, execute a child class, or it is going to execute a parent class? Let's execute it and show it. I think you all know the answer. So here, this is my new Euron Mentor. So it is an object of a child class. So it is trying to execute everything from the child class, not from the parent class. So this is something called as overriding. So I have just overridden the function which I have inherited. Means I have just given my own definition. Name of the function is same. It's not changed, right? So name of the function is same. So I'm just trying to override the old one. This is what I'm trying to perform over here. That's it. Very simple one. This is something which I'm trying to perform in this place. Okay, that's great. So here, right? So okay. So here I'm trying to basically override. Okay, that's fine. But before, along with this override, what I want is that I would like to even execute something which is already available inside the parent class. Means I'm trying to execute this intro. So when I'm calling this one, right? So but inside this, I would like to call something which is already available inside the parent class also, right? I don't want to miss this particular part. So what I can do, I can try to call something called as super. Super is a inbuilt function which is available. So if you have to call something from your parent class, right, you can directly call it with the help of super if you are trying to do a inheritance. So super dot, and then if you are going to call intro, so it is going to execute, this line is going to execute what? So this line is going to execute super. Who is the super of Euron Mentor? Mentor is a super, and there is an intro. So it is going to execute this first, and then it is going to execute this one. As simple as that. So now do this. So here, if I'm going to execute Euron.intro, so it is trying to execute first of all this super, which is available in my parents class. My name is Danshu. So I'm able to get that. And then it is trying to print something from the current one. So here I'm just trying to show you a super. So with the help of super, even though after overriding, right, even after overriding, so I have a way. So I have basically this super way. So with the help of this super function, I will be able to call anything from the parent class, and I will be able to execute it in a easiest possible manner. Okay, now let me show you another example of a super with respect to the constructor init method itself. And some people gets confused in general. So I think you all will be able to clarify your confusion. So class COURSE, class course I have created, and let's suppose inside this I'm creating a constructor, so which will ask for the data while creating an object. So init self, and then we have title title. Okay, now self dot title is equals to title. Fine. Okay, so this is the init which I have written. Self.title, and then I'm trying to write inside a init print function, let's suppose. So print what? So print basically self.title. Yeah, print self.title. So print this one. So whenever I'm going to call my init function, so it should like print this one. Okay, fine. Now, so execute it. Now here, so let's try to create another class called as Euron course. Yeah. And it is going to inherit my course class. Let's suppose course class. It simply means that this property must be available with this one. Yeah. This property, this entire property must be available with this one. This is what it means when I'm trying to do a inheritance. But here, so when I'm trying to create this child class, which is a Euron course, and I'm trying to inherit everything from the course class. So I just wanted to add a couple of more parameters. See here, what will happen? So whenever I'm going to create an object of this Euron class, right? Euron course, I'm going to create. It is going to ask me for this title. Yeah, it is going to ask me for the title. The reason is very simple, that it is trying to do the inheritance, and its parent is trying to look for the title while creating an object. So obviously even it will look for the title while creating an object, right? While creating an object. That is something that we have already seen in the beginning itself. But I don't want to, like, I just don't want to, like, take a title. I would like to take something else as well for a child class. So while creating an object, so just not title. So yeah, title it is going to take, that's completely fine. But apart from title, so I just want my object to take some other data as well, right? Some other data as well with respect to this Euron course while creating its object, its child class object, right? While doing this, not just a title. So how I can do that part? So maybe I can try to create my own init. So while I'm trying to say that I'm going to create my own init over here, title, so which should take a title, yeah, which should take basically a title title, and which should take another variable called as mentor. Let's suppose it should take two things, not the title. So it should take title as well as it should take a mentor. So title it should take, right? Title it should take basically from this one, yeah, and then mentor it should take here, because title anyhow, like, parent class is trying to use it. So self dot mentor is equals to mentor I have, let's suppose, defined. Yeah, self dot mentor is equal to mentor, let's suppose I have defined. Now I'm going to perform a print operation inside this init. So print basically formatted string, and here, so try to print basically self dot title, and try to print self dot mentor. Yeah, try to print self dot title and try to print basically self dot mentor over here. Okay, that's great. Now if I'm going to execute, and if I'm going to execute this object, right? Now if I'm going to execute this object, so now it is asking me for two parameters, title and mentor. Yeah, it is asking me for two parameters basically, title and a mentor. Okay, so here if I'm going to pass my title, let's suppose I'm going to pass Python, and my mentor is basically SUDH if I'm going to pass. Now it has a different complaint. See, previously when I was not giving anything, right? When I was not giving anything, it was not complaining, right? It was complaining like, I give me title and mentor, and when I have given title and mentor both, now Euron course object has no attribute called as title. Euron course, and it's not a highlighted one, as you can see, right? It's not a highlighted one. So I'm trying to create an object of this Euron course, and previously it was having complaint for like a title and mentor. Now I have given that. Now it is complaining that it is having no attribute as a title, and this is not a highlighted one, as you can see in a Python code. So what is the issue, by the way? So see guys, here again I'm trying to perform a overriding operation, right? So I have overridden the init function. So now it is trying to behave, this object is trying to behave as per this init function. So whatever this init function is going to ask, it is going to take that one. So if I'm going to like, so now it is telling me that missing mentor, right? Missing mentor, by the way. So here the problem is that, let's suppose I'm going to remove this title. Yeah, I'm going to remove this title. So in Euron course has no order to call a title. Okay, so now remove even this particular part. Remove title itself. Everything remove it. Now it's fine. Now it's fine because I have just overridden. Simple, right? I have just overridden the init. So now there is no relationship between this title and this mentor at all. Relationship is gone basically, right? But no, that should not happen. So I was looking for a title as well as mentor. That was my requirement. So I was looking for a title from my parent class and then mentor from my Euron courses. That was my original requirement. Now, how I can fulfill that original requirement? So I think we already know the way. I have already told you, super. So let me show you with the help of that one. So here I'm going to create a title title, right? And I have to use a title from above. Like I have to use basically a title means init, right? So whatever variable which init was taking, I have to take that one. So here what I can do is I can call a super once again dot what? So dot init. So use a init of a super and then initialize what? Initialize title. So initialize title is, or you can write even in this way. So initialize title is equals to title. Yeah, means this title, right? This title I'm trying to initialize with this local title, which I'm going to pass eventually. So it is going to invoke what? It is going to invoke my parent class constructor. Yeah, it is going to invoke my parent class constructor. Now title value will be available. And if you would like to print the title value, so just try to like do self dot title and you will be able to print. Now, via this approach, it's very simple. It looks like sometimes tricky when you will look into this for the very first time, but it's not at all tricky. Yeah, it's very, very simple. So here, super init and title or title, and I'm able to print each and everything. Yeah. Now, so if I'm going to pass like a mentor and title, so let's suppose title, course title is Python. Now it's working fine. Now it's trying to call this Python. Now from where we are getting a Python? Print Python from this one. So it is trying to invoke what? It is trying to invoke basically this init as well. And it's trying to print. See, it is printing, right? And then it is trying to print this one. So which is coming from my child class. So in this way, I'm able to use a init which was available in my parent class. I'm able to pass a variable which was required by or data which was required by a parent class init class, and then I'm able to create a child class init where I'm able to pass something more, right, which is a requirement of a child class. So in this way I will be able to perform again the inheritance, and here is the super method. So with the help of super, in a previous example I have shown you something I can try to call from the parent anytime I want, and then again, so even like a inbuilt function, I'm able to call it over here. Okay. So now let's try to understand a couple of more things with respect to the inheritance. So far we are able to do a good amount of inheritance. Now let's try to show you, let me try to show you a multiple inheritance, right? Sorry, multi-label inheritance, and then I'll show you multiple inheritance. So here, let's suppose I'm going to create a class called as platform, FORM, platform. Yeah, class is platform. Def dot show. So this is going to print something. So def dot show print. This is my Euron platform. Yeah. Now there is another class I'm going to create, class, right? So I'm going to create basically a course, and course is trying to inherit platform. So obviously this show will be available, right? This show will be available. And here, so I'm going to create a function. So display course. So this is going to print basically print what? So this will give you a course details. Yeah. So see, there is a course class trying to inherit a platform class, PLATE, whatever is the like spelling, it's fine, leave it. So here this course class is going to inherit something from the platform class, right? So something it is going to inherit from the platform class. Something means this function. So this course class will be having two functions. One is its own function that I have already created, display underscore course, and one function is a show function. So if you are going to create an object of this course class, obviously it is going to show you both show as well as this one. Now I'm going to create another class, right? Another class called as DSA. Yeah, DSA. And here I'm going to inherit basically course and def intro. print this is my DSA course. Yeah. So now this DSA is calling this course. DSA is calling this course. Course is calling this platform. So and now course will be having access of two functions, show and display. Now DSA will be having an access of three functions. So one is a intro and two from the course. Course is having two access, right? This show and display courses. So here to just to prove that, right? So here object of DSA I'm going to create. So object of DSA I'm going to create. Now if I'm going to call the object dot, you will be able to find out that it is having an access of all three. One from the platform. See, in a DSA I'm not directly calling this platform. I'm calling courses and course is calling platform. So here you can say that this is my child. So this is maybe my child. This is my parent for DSA by the way, and this is my and this is my grandparent for a DSA. Simple, right? So child, parent and a grandparent. So in this way, I'm trying to invoke this one. So obviously DSA will be having access of intro, display courses and so all these things. Now this is called as, right? This is called as multi-label inheritance, as simple as that. Yeah. So multi-label inheritance, we are trying to do it. So, okay, that's amazing. So here one by one, just try to call the show and I'm able to access this is the Euron platform, then ds dot display courses. So we'll try to like call something from the courses and then ds dot basically intro. So it is going to give me the intro from the DSA class itself. Yeah, DSA class. So I can try to even call in this way and in a multiple hierarchical way and as simple as that. So whatever is available to its parents, it will be available to the child. It's as simple as that. Okay. Now, so I'm going to show you something different over here. So multi-label is completely fine. I'm going to show you a multiple. Multiple means, let's suppose I'm going to create a class design. Yeah, class design. And here, so I'm going to create a function called as UI. I'm going to create a function called as UI self. And then I'm going to do the print. So this is my system design. Okay, fine. So this is one of the class that I have created. Then I'm going to create a separate independent class, curriculum, let's suppose. And it is not going to inherit anyone. So again, it's an independent class. And here, so def syllabus self and print curriculum loaded. Yeah, curriculum loaded. Now these are the two class which I have created. Now there is a third class I'm going to create, Euron system class. And here, so I'm going to call a design class as well as I'm going to call a curriculum class. Yeah, here I'm going to call the curriculum class and then I'm going to call pass. Fine, I'm going to call a pass over here. Now here, as you can see, this one single class is trying to inherit two classes, right? One single class is trying to inherit two classes. Now if I'm going to create an object of this Euron class, Euron system, Euron system. Now, so what and all things are available? Both. Something from a design and something from the curriculum is available to me. So from a design, I have a UI method which is available, and from a curriculum, so I have a syllabus method which is available to me. So EU dot and then UI. So both from both the class, from both of this class, I have something which is available inside my child classes, right? So I'm able to do a multiple inheritance over here. I'm able to inherit a multi-class. So this is called as multiple inheritance. Yeah, so this is called as technically a multiple inheritance. So successfully we are able to, like, inherit something from a multiple classes inside one single child class. As simple as that. Okay. Now, so here, when I'm able to create an object, right? So when I'm able to create an object, so there is something called as MRO. Uh, mm, 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 mm. Or I can call this Euron system dot MRO. Yeah. So here, this there is something called as MRO, method resolution order. Yeah. So basically, this MRO always try to tell you that whenever you are going to give a call, so whenever you are going to call an object of this class, Euron system, right? Euron system class. So MRO always tells you that what will be the priority, right? What will be the priority? Which one will be called first, and which one will be called second, and which one will be called technically third? That is something called as MRO, method resolution order, right? So here you can try to print MRO for any of this class. Any classes you can try to print MRO, by the way. Any class, not just for this class. For any class you can try to print the MRO in a easiest possible manner. Even the previous class that we have created, right? This class that we have created. So even for maybe a DSA class, I can go ahead and I can try to print basically dot MRO. Yeah, MRO. So now it says that which one will be given a first priority. So if I'm going to call an object of this class on which I'm trying to print MRO, right? So if I'm calling a DSA class, so first priority will be given to a DSA class itself. Second priority given to the course class, right? And third priority will be given to the platform class. So this is technically order it is trying to print. Similarly, so here you will be able to find out that it is trying to say that, okay, so first priority will be given to the Euron system class. Second priority will be given to the design class, and third priority will be given to the curriculum classes. So whenever you get confused, just try to print a MRO, and MRO is going to tell you that, okay, so this will be the order, or this will be the priority I will try to give in terms of inheriting some of the properties, right? So some of the properties from my parent class or maybe from a grandparent class. This is the use of a MRO, which is a inbuilt one, and with the class you can try to call your MRO. So with that, guys, hope all of you are able to understand a lot with respect to a inheritance, with respect to a super method, with respect to a MRO, multiple and a multi-label inheritance, and hope all of you are going to solve the assignment and all of you are going to use this entire concept. With that, thank you so much everyone. Take care and see you again in my next lecture.